One useful series that comes up when we're talking about the integral test is a series called the p series. So if we were to consider what values of p that the series from k equals 1 to infinity of 1 over k to the p will converge. So let's take a look at this guy. And this is very, very similar to an integral that we looked at back when we looked at improper integrals, 1 over x to the p dx. So recall this from integration, from improper integrals. So remember, we looked at this guy when we looked at improper integrals, and we went through a whole proof to determine for which values of p this would converge. So in general, if we think about the function 1 over x to the p, these are positive decreasing functions for x greater than or equal to 1, and we can use the integral test. And notice that if this is an integral, we already know when it converges and when it diverges. So this is just coming right out of a proof that we did in class in the improper integral section. So this proof right here, we already did. We did this in class. We came up with this result. We knew that if the integral from 1 to infinity of 1 over x to the p dx would converge for p greater than 1, and it would diverge otherwise. So that said, we can compare this to, not compare, we can use the integral test, just use the integral test and say that the series, remember the series is going to do the same thing as the integral. So the series from 1 to infinity of 1 over k to the p is going to converge if that power on k is greater than 1, and it's going to diverge if that power is less than or equal to 1. All right, so that said, let's just check out a couple of examples. So let's determine the convergence or divergence of the following series. And this guy, notice, is equivalent to saying, so we're looking at the series from k equals 1 to infinity of k to the negative 0.9. Well, this is exactly the same as saying 1 over k to the 0.9 from k equals 1 to infinity. Clearly, p is equal to 0.9, which is less than 1, and we can say that this diverges by p series. And if we look at this one, so here we're looking at the series from 1 to infinity of 1 over k to the 5th. Obviously, on this one, we don't even have to do any sort of work. We can see that p right there, and we can say that p equals 5, which is greater than 1. This series is going to converge by p series. And we're done. All right. Okay, and then we come across this guy. So if we take a look at this one, so here we're looking at the series from k equals 3 to infinity of 1 over k minus 1 to the third. And I just want to, just so we can illustrate here, because what I did here on this one was I changed the index a little bit. I have this k minus 1, but what I want when you're looking at something like this, what I want you guys to see here is that this is really just a shifted index. And so what we're kind of thinking about is this is similar, very similar to a series from, let's just use a different letter like j to the third. This is really similar to something like that. It's just a shift. It's just a shifted index. So we're really similar. We kind of keep this in our mind. And we think about, well, what does this look like? Could I shift it? Could I use my p series here? And the answer is absolutely. This is almost exactly the same as looking at the series from j equals 1 to infinity of 1 over j to the third. We might be missing a couple of terms. We might have shifted a little bit. So take a look. If we plug in 3 here, we would get 1 over 2 cubed, so we'd get 1 over 8. And then the next term, if I plugged in 4, would be 1 over 27. and then the next term would be 1 over 4 cubed when I plug in 5, so 64. So notice that's what this series looks like, right? Here's just the list of terms, or here's just the sum of the terms. So here's what the terms look like, just a shifted index, and we can easily adjust for that. So what we could do here is we could just say, why don't we actually do that index shift? So index shift. This is equivalent, I can say, from the series from k equals 3 to infinity of 1 over k minus 1 cubed would be equivalent to, let's say this. Let's pick any variable you want. I'm going to go ahead and just go with n. Let's just say let n equal that k minus 1. So if n equals that k minus 1, then this would be equivalent to 1 over n cubed. Now I just have to figure out where the index should start. So where does n start? Well, if k equals 3, then n would start at 3 minus 1, so n would be 2. So this would start at 2 to infinity, and we can see that is exactly, this is equality, that is exactly equal to the series that we had above. Just a quick little index shift, and we can see that we get the exact same series. This is very clearly a P series in the exact form. We've just shifted. The index doesn't start at the same value, but that doesn't change the convergence or divergence, for that matter, of a series. So where you start the index of that P series actually doesn't matter. It's just the difference of either adding or subtracting a couple of terms from a finite or infinite number. That won't change the finiteness of it or the infiniteness of it. So this is still a P series. This is exactly a P series here, and we could say, therefore, this is P series, P equals 3, which means this converges. We should say one more thing. P equals 3, which is very much greater than 1, so therefore this converges by P series. And now the P series, so just to reiterate, those are three very quick little examples, and P series should be pretty quick. It's a matter of identifying that it is a P series, right? You might have to do a quick little shift on the index, but it's a matter of identifying that it's a P series and that the P series will converge if P is greater than 1 and diverge if P is less than or equal to 1. So keep this in mind. This is going to be a very useful series when we move forward into our next set of tests, which are called comparison tests. And in the comparison test, knowing that it's something that's similar or could be compared to a P series will come in really handy, because we know exactly just by looking at a series, if it's a P series, we know that it will converge or diverge based on whatever that power is.